AI is moving so fast, and also we have a lot of open source AI tools that mean they are completely free. We have a video generation system that can explore an entire virtual world and stay perfectly consistent for hundreds of frames in a row. We have the world's first open source 1 trillion parameter thinking model, and it just scored gold medal level on 2 of the hardest math competitions on the planet. We have a brand new text-to-speech model that runs in real time, that clones voices, handles multiple accents, and needs only 3 gigabytes of GPU memory. We have a video editing tool from Meta that edits your video 10 times faster than anything else, and a lot more. So let's jump right in. First up, researchers from Meta Reality Labs and Carnegie Mellon University just published a video editing system called EditCtrl. Here's the problem it's solving. When you use AI to edit a video, existing systems process the entire video, every frame, every pixel, even the parts that aren't changing at all. That's incredibly wasteful. If you're only changing 10% of the frame, why are you spending compute on the other 90%? So EditCtrl solves this problem. Here's how it works. You define a mask, the region you want to change. You give it a text prompt describing what you want. The EditCtrl process only runs on the masked region. The rest of the video stays untouched. Then the newly generated content gets composited back in. Here are some examples. You can say add a UFO, add a fire-breathing monster, and add a portal, all in the same video with 3 separate masks, and it handles all of them simultaneously. Similarly, in this video, it edits and changes the flower color to blue. You can also remove objects from video, like in this video. It removes the goat, and the results are amazing. You can also change property attributes and edit multiple regions with different prompts. EditCtrl is 10 times more compute efficient than the current state-of-the-art generative editing methods. But it's not just faster, it actually produces better edits too. The code is available on GitHub, link in the description. Next up, a research team from the University of North Carolina, NTU Singapore, and the Allen Institute for AI published a paper called AnchorWeave, and it tackles one of the hardest problems in AI video generation, keeping a scene consistent across long camera movements. AnchorWeave uses multiple small, clean local memories, one per viewpoint. When the camera needs to look back at somewhere it's already seen, the system retrieves the relevant local memory and integrates it using something called a multi-anchor weaving controller. As you can see here, the world is consistent across the whole video generation. And there are lots of other examples here. AnchorWeave significantly improves long-term scene consistency on standard benchmarks while maintaining strong visual quality throughout. The backbone is built on WAN 2.2, a 5 billion parameter video generation model. Code is on GitHub. Paper and demos are linked in the description. Next up, a team called inclusionAI just released Ring 2.51T on Hugging Face. And this is the world's first open source trillion parameter thinking model built on a completely new architecture called hybrid linear attention. Now let me explain what makes this special. Most large AI models hit a wall when generating very long outputs. The more tokens they produce, the slower they get, and the more memory they eat up. Ring 2.5 solves this with a hybrid architecture that mixes 2 types of attention. It reduces memory access overhead by more than 10 times and increases generation speed by more than 3 times for sequences longer than 32,000 tokens. They tested it on IMO 2025, the International Math Olympiad. Full score is 42 points. Ring 2.51T scored 35. That's gold medal level. And on CMO 2025, the Chinese Math Olympiad, full score is 126 points. The gold medal threshold is 78. Ring 2.51T scored 105. That completely blows past the gold medal cutoff and even past the national team selection score of 87. It also beats other open source models on coding benchmarks, logic reasoning, and agent tasks like software engineering and complex tool calling chains. The context window is 128,000 tokens and can be extended to 256,000 using a technique called yarn. The awesome thing is, the full model is already available for download right now on Hugging Face and ModelScope under the MIT license. That means you can use it however you want. A chat experience and API are coming soon through their Ling Studio platform. I'll link to the Hugging Face page in in the description below. Next up, a company called NineNineSix just released Connie TTS on Hugging Face. It's a text-to-speech model optimized specifically for real-time conversations, and the specs on this thing are genuinely impressive for how small it is. The model is only 400 million parameters. What that means is it generates audio roughly 5 times faster than real-time, so a 10-second audio clip takes about 2 seconds to generate. Memory required is only 3 gigabytes of VRAM. That's nothing. The model was pre-trained on around 10,000 hours of audio data. Training took just 6 hours on 8 H100 GPUs, which is surprisingly fast. They have audio examples on the page showing different voices. Frank from Boston.
What's up, kid? Nah, just watching spring training highlights. Socks looking okay, but you know how it goes.
Jermaine from Oakland.
Yo, I was hella craving some Louisiana fried chicken last night, so I slid through, waited 35 minutes in line just to get the 2-piece with the mild sauce.
Rory from Glasgow with a Scottish accent.
Last night's game, the old firm, aye. My team gets pumped again, pure murder. I'm sitting in the pub with my pals screaming at the telly. Then some bampote from the other side starts gloating.
Batty from Liverpool with an English accent.
Hey lads, the weather in Liverpool today, boss rain in it. I woke up thinking I'd go for a walk down the Albert Dock, but nah, it's pelting it down like the Mersey's over Foon.
The accent diversity is something TTS models usually struggle with. This one handles it. The awesome thing is it's fully open source, which means you can even use the pre-training framework they've released to train your own version in a different language from scratch. If you're building a voice chatbot, a podcast tool, or any kind of real-time audio AI application, this is worth trying. Anyways, the model is on Hugging Face, link in the description. Next up, Alibaba's PAI team just released something useful for anyone doing AI image generation. It's called Z-Image-Fun-Lora-Distill. Here's what it does. Z-Image normally takes 25 steps to generate an image. This LoRa distills the process down to just 8 steps, so generation gets significantly faster. The team is honest about it. The output quality drops slightly compared to 25 steps, and there's a current issue where the results come out a bit brighter than expected. They're actively working on fixing the brightness and plan to train an even faster 4-step version soon. It gives developers building on top of Z-Image a fast option that still plays nicely with their customizations and controls. The model is available right now on Hugging Face under the Apache 2.0 license. I'll link it below. Next up, this research paper from LMMs-Lab is genuinely fascinating, and it was the number 2 paper of the day on Hugging Face when it dropped. It's called OneVision-Encoder. When you watch a video, most of its background doesn't change. Only a small percentage of pixels carry real information. Current AI vision models just process every single pixel equally, even the boring background. They waste enormous compute on stuff that contains basically no information. But OneVision-Encoder fixes this. It uses what they call codec patchification, borrowing the logic of video codecs, to identify and focus only on the 3.1% to 25% of regions that actually contain signals. The rest gets ignored. And here's what makes this so exciting. It actually improves accuracy. When plugged into a language model, OneVision-Encoder outperforms Qwen 3 VIT and Siglip 2 vision encoders across 16 different image, video, and document benchmarks. Understanding specifically, it improves on Qwen 3 VIT by an average of 4.1% while using substantially fewer visual tokens and less pre-training data. This could be a big deal for anyone building vision language models because it means you can get better accuracy at lower compute cost. And finally, China universities just released REDSearcher, and the results are seriously impressive for an open-source, smaller-scale model. REDSearcher is a search agent framework. It's designed to handle long-horizon research tasks, the kind where answering a question requires searching across multiple pages, combining information from different sources, and reasoning across steps. The key innovation here is how they trained it. Most AI research agents are trained on simple, single-hop questions. The answer is one search away. REDSearcher trains on much harder problems that require multiple hops, where you have to find one piece of information, use that to search for the next piece, and chain them together. The benchmarks are where it gets interesting. On GAIA benchmark, which tests its general AI agent ability, REDSearcher scores 80.1%. That beats GPT-5 and also Gemini 3 Pro. On BrowseComp, a benchmark for hard web research, REDSearcher scores 57.4% with their context management technique. That competes with models much larger than it. And they also released a multimodal version, REDSearcher MM, that handles both text and image-based search tasks. On the BCVL benchmark, the RL-trained version hits 57.2%. The awesome thing is the training datasets are already available on Hugging Face right now. The model weights are coming soon, and the full code is on GitHub. For anyone building research agents or trying to understand how to train them properly, this paper is worth reading in full.